One of the things that I would share with you is that since our last session, a new version of Windows has rolled out, an update, actually, a cumulative, what's referred to as a cumulative update, but there were major changes. It did scramble the eggs on my own system, and it disrupted my network connectivity for a time. I also had to start work on reclaiming a virtual machine, and I'm going to walk through that on screen shortly so you can see how that process works. So basically, what I'd like to do is help you troubleshoot some of the issues after we review your next assignment. So inside the Coding Essentials, Coding and Database Essentials module, module 3, the 3.2 CS Dojo, right, assignment, that's what we covered in our last session, correct? We went through, yes, we went through CS Dojo. And once again, you had several options to install or use Python. So you could use Python natively in the PG book, or you could install Jupyter Notebook, which is a component of Anaconda, as a part of your exploration as you followed along with YK. Once you have completed, do not go out of order. Having finished 3.2, when you look into custom functions, this stuff gets really powerful and very almost intuitive. One of the things that we want people to understand about coding and custom software is that you can create and should create complete, discrete, self-sustained or self-capable functions, right? So how many of you have heard of the term object-oriented programming?
I have.
Right.
Data structures, things like that.
So on a very fundamental level, and I'm oversimplifying here, okay? I'm oversimplifying. When you create a function, a specific software task, a function, it performs a given operation, and when you call that function, it does the job. So you can have 3 different functions for 3 different tasks, and then you can take that function and you can reuse it in other software. Put another way, each of those custom functions I was talking about, function A, function B, function C, and these are just hypothetical function names, right? Once I've created those functions and I know what and how they do, and I understand how to call the function, the cool part is that I can basically use each function like an object. Now, again, I am oversimplifying here, but I'm just trying to explain in very basic layman's terms. If I learn how to create a function, I am essentially learning how to create a small piece of machinery I can reuse and transplant into other software. I'm creating a digital object of sorts, and I can reuse that object. So in a very basic and very sensible level, when you learn how to do this, a lot of new possibilities open up for you as you learn how to work with creating your own custom software, right? And one of the things that I wanted to tell you is that after you finish your, and this should read 3.3, okay, so I got it, let me fix that right now. Not sure how that happened, 3.3. There we go. 3.3. So once you finish 3.2, one of the things that you'll notice is that I'm asking you to do a reading assignment, right? So I'm asking you to handle assignment 3.1 prior to completing this. Oh, again, that should read 3.2. My bad. You fix that. 3.2. Everybody still with me?
Yeah.
Okay. Now this is still true. Then read section what? 4.3.3 of your textbook. Specifically the bottom of page 126 through 139. Now, if you don't do this, if you don't complete assignment 3.2 first, then you don't read your textbook, some of the rest of this stuff that we're going to do on screen isn't going to make sense. So I'm all for helping students and sharing a screen, but I just want to share with you that I'm going to ask if you've read the whole assignment, and then I'm going to say, okay, did you finish 3.2? And then I'm going to look on my screen, and and if I don't see anything submitted, I'm going to say, well, where is it, right? Because it's a dependency here. The concepts we're learning in 3.2 are building blocks for this one. Then I'm going to ask you about section 4.3.3. And why am I doing that? Not to be difficult, but the simple truth is you have to have these extra, you have to have this extra information for the rest of this to make sense. Now, once you've worked through the tutorials and read the related concepts in the textbook, you will also be ready to work up the quick creation of a custom function and run it repeatedly in the PG book environment. So you can basically see how, okay, that's handy, it's there, it's working. All I have to do is bloop, one quick command, boom, and the whole thing goes off running, right? Now, you want to customize the examples so you submit so they reflect something about who you are on screen. Does everybody see this? This part, this piece? Customize the examples so they reflect something about who you are on the screen. When you turn in your submission, I do not want to see what was in these examples, right? You'll see what I mean when you read this stuff. You'll have a chance to use your own name, your own ideas, and apply them by that direction. So using Python, repeat the commands shown at the top of page 131 in your textbook. Now, what's at the top of page 131 in your textbook? Can everybody see my screen?
Yeah.
Yeah, we can see it.
Yeah, this is a screenshot of page 131, okay? So basically we're talking about how most introductions of coding do a poor job demonstrating the principles of self-description. Well, our textbook authors are no exception. Here's a great example of how to use a type function to display what data type is used or stored in this variable called I for integer. And I'm going to store or declare, the formal term is I'm going to initialize and declare this variable called I by storing the whole number 1 inside I. Once I do that, I can use the type function, and then as an argument or as a extra element, I can use that variable and put it right in here after I've stored the number 1 in here, a whole number. What I'm going to get back is, okay, this is an integer. So the type function is going to look at the whole number 1, and then it's going to say, this is an integer. Is everybody with me so far?
Yeah.
Okay. Oh. Now I'm also going to, in Python, store a value, a numerical value with a decimal point. In some circles, this is referred to as a floating point number, or, or a real number. It has decimal points, R for real. I'm going to store 2.345 into R, and then I'm going to use the type function. This time, instead of I'm going to use R. And the type function is going to return, oh, it's float, meaning floating point. Now, here's the fun part. And this is the piece I want you to understand. A lot of times we have errors in coding because of the way different types of data interact with each other when they're used in a command. So here we have a whole number, and here we have a decimal number, and we're multiplying what was stored in I and what was stored in R. We're multiplying before it is fed into the function called type. So I have an integer and I have a floating point, and I multiply the two by each other, and that calculation results in a floating point value. Put another way, I had an integer, but when I multiply it by a float, now what I have left is a floating point result. And now type is going to tell me, oh, you have a floating point type. Now, what's the benefit of this simple activity? You need to understand that when you use programming commands with different data types, they sometimes transform or change each other in a sense. Okay? So we take a whole number, we multiply it by a float number, we don't get a whole number back out. That's important to understand conceptually, because sometimes, well, data types change and that can be bad. Here's a good example. Birth dates, zip codes, phone numbers. Those are numbers, but they're not intended to be used for mathematical calculations. They're actually of the data type string. They're characters used to describe where someone lives or how to reach them on the phone. And when you put in type, what you get is string back, which means those numbers aren't numbers in mathematical terms. They're numbers in descriptive language terms, right? And if you try, guess what happens if you try to perform a calculation with numbers that aren't really numbers? What happens to,
Syntax error.
yeah, what was that again?
Syntax error.
You get an error. That's correct. You get an error because you're trying to use the data type, and you're looking at a zip code. And when you look at the zip code, you think, I have a 5-digit number. Nope. I have a string of 5 characters that represent the numbers that relate to a given community that the post office uses to deliver packages and envelopes, right? It's a zip code. It's descriptive in a different sense. And that, ladies and gentlemen, is a key source of errors when you're trying to do simple stuff. Another problem is that we use these simple, these crazy, these nutty one-letter variables. And that's always problematic, because the moment we see a single letter variable, we're thinking, oh, I'm in algebra again. That's the back of your head talking. And what I want you to understand is that this equal sign is not an equal sign. It's an assignment operator. I'm taking the whole number 1, assigning it to the integer and to an integer variable, which I have labeled I. So when I say, hey, I want you to customize the examples you submit so they reflect something about who you are on the screen, right? What I'm saying is that when you're doing these things, take the time to walk, take the time to walk through this. Where are we? Where do we go? Right here. Take the time to walk through this. Can everybody see this?
Yes.
Now, why in the world would I ask you to label your integer with your name? Well, it could be that in the software that I create, I am trying to capture some important element of data about myself, right? So what am I saying? Here you see that I've used int to represent the idea that this is, okay, I know that this variable has something to do with Timothy Kentop, and I know what's stored in there is an integer. So when you do this activity, that's what I mean by personalizing it. I don't want you to use I. I want you to use a sensible designation for what that data type is. You can use FLT for float. I don't want to see an R or an F. I want to see FLT, and then I want to see your name written just like I did right here. And if I don't, I'm just going to post no credit. I'm going to say, well, you didn't do this. Now, this is a very simple thing, right? You can follow along with it. You can substitute your own name, and you can walk through the same process. And when you're finished, you take a screenshot of it. And what I'm going to see on the screen is something that looks like this, except it's personalized. And I have a better idea from what's on the screen about what kind of data type I'm using before I ever have to use the type function to verify. Again, this is a major source of programming error. People write simple code and it doesn't work, and they're like, I don't know why. Well, they don't know why because there's a simple conflict with the data type, right? And or the type of information that's supposed to be in here about you isn't correct. It's not in the right format. So when an error shows up and you see this, and you're looking at what went into it, the first thing you're going to verify is, okay, does this have to do with the data that I know is correct for Kentop? Is it whole number? Is what's stored in there a whole number? Like his age in years, whole numbers, 62. If I see 59.75, but I know it's supposed to be an integer data type, I know that the very next task in my program may misfire because I'm not being consistent. So these are tricks of the trade, right? These are tricks of the trade where you can kind of keep things straight. And so I want you to walk through this and humor me, but then personalize it. And that's the first part of your assignment. Any questions about this? About this part of it?
So the cluster example will show us how to do it, right?
The short answer is yes. If I heard your question correctly, you said
Sorry. Yeah, the custom function.
yes. In each of these cases, for part 1 and part 2, you want to work the task, but you want to make sure that it's customized for you. Because if I see the same thing that I did, I'm gonna say, well, hey, I know a 3rd grader that can copycat. I mean, seriously, I know a 3rd grader that can follow along with this video on YouTube, and they can pull up a screen and they can, I type this, they type this. I type that, they type that. The trick is whether or not you can modify it for a given different circumstances with different information. And will it work the same way, right? Crawl, walk, run. After you've had a chance to get familiar with what YK shows you in the CS Dojo, right? This should be a piece of cake. Now, I also give you a sample of a data type program. No. That's not the one I wanted to open. My bad. Hold on. I also give you a sample of this is the one I wanted, a custom program, right? So I explained some things about how functions work. And basically, a function, the first thing you do is you define a function. And YK goes into this. In his video segments, YK explains how to set up a function and then how to use a function. But there's a piece of it, right? YK does not explain that use of a function is best done by defining first a main function that calls each of the functions that represent the steps of a task. So let's go back to this screen again. Whoop, I'm sorry. This, oh, my bar keeps coming down here. This, was it here? Yeah, this. The best way to use functions is to start with a main function. YK didn't explain that in his video. And what am I saying? You have a task and you create a function for each task. And then you create a program by creating a main function. You define a main function. And then you call the function. So what are we looking at here? This is something that seems a little circular, but I want to walk you through it. The first step that YK teaches you is that when you create a function, you have to define a function. Let's take this example first. Here I have a function I'm defining, and I'm defining it by using this character. So if I say def, that means, okay, I'm going to define something. And then when I put these brackets here, the parentheses, it says, oh, all right, I'm going to define a function. And it's going to be, its purpose is to greet, to say hello. Is everybody with me? And what data, and what data type is it? It is a string data type, which means I have characters I'm going to use for a hello. So it's string hello. Everybody with me so far?
Yeah.
So once I have this piece here, now I just do the function. I indent some spaces. In Python, you want to indent the same number of spaces all the time, or it just doesn't work. That's another thing about Python that gets a little sticky. I will tell you that if you're watching along with the YouTube and you're doing it on your own screen, and you're off by one space, what will happen is it'll run the first line, and then when it gets to the different number of spaces, it'll misfire, right? So that's a common problem that people bang their heads against the wall with. But here, all right, I've started to define my string hello, and it's a simple print command. Print, greetings, Earthling, I come in peace and offer an end to starvation. That's a nice hello. So that's my function, and it's called string hello. Now, if I'm going to create a program with string hello, the best way to do this is not to just call string hello. Again, YK shows how to create a function and then to call a function. But what he doesn't do is he doesn't show you how to work with objects. If I'm creating a main function, the purpose of my main function, purpose of my main function is to call other functions, okay? So the main function calls the other functions. That's its purpose. And it's considered a best practice to work that way, because if I create everything I want to do in programming as a function, I can reuse it. I can reuse it over and over again. Why would I want to redo it over and over again? Now, you might not think this is magic, but I want you to imagine for a second. Is everybody with me? I want
We're
everybody,
with you.
yeah, I want everybody to unmute your mic. I want to hear I want to hear 8 voices right now. I want to make sure you're all on board with this because we all multitask like busy
The
little,
thing I'm thinking is, if I'm going to be doing Python, do I need a program for it, or?
that's where the Anaconda comes in. The Jupyter Notebook or your PG book. Both of those environments have Python built in. It's ready to go. That's a good question. I'm glad you asked it. Okay, now,
I have a quick, I don't mean to interrupt, but I have a quick question kind of to follow up to what he asked.
yes,
Is it the same thing for the terminal 2 for those of us on the Mac?
is it the same thing for the what?
Is it the same as in like for the terminal that we can also use the Python, because we use Python on the terminal for the MacBooks?
That's a great question. You might have to go to the App Store and install Python on your Mac.
Okay.
Okay, and there is where, I mean, if you have a Mac and you can run the PG book, then what you're seeing on the screen is consistent with what's in the PG book for everybody. But if you want to be a Mac pioneer because, well, you want to do your own thing, you want to be an individual, that's good. Well, then part of being a pioneer is going out on the App Store and going, which flavor of Python do I want to run on my Mac? What I would advise is that you check that out and then give it a try. And if you run into snags, give me a shout and we'll walk through it together, okay? And you don't have to apologize for raising a question. I'm glad you did, and that's why we are trying to do this, where I do something and then show you and then you do something, right? There's going to be questions along the way. I just wanted to make sure I heard from everybody that everybody's with us before I say the next thing. Okay,
I'm here.
Yeah, here.
good. This whole idea of a function and object-oriented programming doesn't seem very exciting. But I want you to imagine a case where you're learning how to use a saw to cut a board, so you can use it to build stuff. Are you with me?
Yes.
Okay. And
Yeah.
guess what? You cut one board and you don't ever have to cut another board again. And then you use a function to fasten the board to something, a screw, a nail, right? Okay, so you decide what is it going to be riveted? Is it going to be bolted? Is it going to be screwed? Is it going to be nailed? The point is you come up with a function to nail boards, and then you never have to swing a hammer again, because you do it once and then it's like magic. You don't have to lift the hammer and keep hammering away and get physical all the day long until your muscles are sore. You figure out how to do it once, how to do it right, and then from that point on, forever and ever, amen. You never have to lift a hammer again, but you're nailing like a wild man. Okay, now it just doesn't sink in how powerful this stuff is. Okay, so I'm going to be a bit of evangelist along the way, but we have a very simple example here, and I want to make sure that this very basic example we nail, excuse the pun, nail home the idea of the reusability thing. Okay, now let's get back to this. The main purpose of a main function is to call other functions. Just remember that. What does a main function do? Well, it's the lead function, and if I'm doing functional programming, then once I call the main, it's gonna call whatever function I want inside there. Now, you'll notice I have defined a main function first. And what does it call? String hello. Everybody see that?
Yeah.
Does that look familiar? Please say yes.
Yes, it does.
Okay, good. We just defined the string hello function. So it calls string hello, and then lo and behold, here it is. So it knows what to do. Okay, so you have all these other objects, you have all these other functions. And here's what happens when people use main functions. They define the function, they list the functions it's going to call, and then it doesn't run And then it doesn't give you an error. And this is one of those things where it's like, if I could devise a programming language that was a little kinder and gentler to people who wanted to learn how to code, because it's magic, I would occasionally include simple things like, hello, this is why your main isn't working. I've defined the main, it calls string hello. I've defined string hello, so when it's called, the string hello function knows what to do. But the last thing I forgot to do was actually call main itself. Hello. Let's say that again. I created main, I defined it, but then I never used it because I didn't call it. And see, people watch YK. They watch his videos and they think he's cute. And you can tell he's from Japan. He has that Japanese accent, you know, and he makes perfect sense. And I walked through this 20-minute video and now I'm a rock star when it comes to creating functions. Except when you start putting them together and the next step is, okay, let's reuse them because that's powerful. And you get to that point where you define the main function and which other subordinate functions it calls. But the last step is often omitted. And it's excruciating because there's no error on the screen. It won't tell you, hey, what's wrong? It'll just sit there and blink at you. Like, what are you, dumb? You created a main function, but you never used it. When you use a function, it's called calling a function. When you see the colon, it's preceded by the term def, meaning, okay, I'm defining the function. So calling a function is this simple. Defining a function kind of looks the same. So if you don't take the time to kind of sort this out, it can get confusing in a hurry. And this is a very basic program, but it's 100% function. I have a single function called greetings, earthlings. I come in peace and offer an end to starvation. Yay! Instead of eating us, they're going to help us solve all the problems in the world, and we're going to end starvation, and that's going to cause a lot of crime to go away. Maybe, I don't know, unless people can't agree with what they're eating. That's another story for another day. So we have this one function. I'm going to use a main function to call the one function. After I define the main function, I'm actually going to use the main function by calling it. Did everybody follow what I just said in the last 20 seconds? So I'm gesturing on the screen as I'm talking through this. And all right. Now, what's the next step? In part 2, I want you to actually build the darn function. I want you to go into PGBook, open Nano, the text editor. If you're on a Mac, you can use your own text editor inside the Mac. You do not have to use Nano. If you're in Raspberry Pi, I think Nano is included in the Raspberry Pi, is it not? Raspberry Pi users, yes, no? Nano? Yes, no, Nano? It's in there. I thought we had somebody that was using the Pi in there. Where's our Pi aficionado? Desi. Desi, aren't you using the Pi, or am I thinking of somebody else? Desi? Calling Desi. Okay, this is the part where I'm going to have to go back and edit this out because we're going to post it on YouTube and I don't want to embarrass Desi. Are you there, Desi? Okay. Is anyone else near Desi? Is he in the classroom over on St. Thomas?
Seen him.
Yeah. All right.
And even then, I'm kind of not in the classroom,
I gotta say hello.
so I can't really reach him.
I just put
Can I
something.
just step away?
Okay. All right. Well, as long as he's still breathing, and all right, we're right. I'm gonna edit that part out. Okay. Yes, you have Nano in a Raspberry Pi. So, but on a Mac, it's going to be something else. It won't be called Nano. you have a text editor, and I think it's actually called text editor or something like that. Create a file named greeting.py using the code example, except you should insert your name where first name is shown in the greeting statement of the sample. You do not get credit. I said a couple of minutes ago, I know a third grader who is great at parroting what I say and what I write. I make a statement, they can make a statement. It's my granddaughter, actually, and she's 3 years old, not a third grader. I can write a sentence and she can write a sentence. What I want you to do is to do the same thing we were just looking at, except where it says first name. Oh, that's right. So the sample here should say, instead of greetings, earthling, maybe this sample should read greeting, insert first name, right? So you can use your name right here for the hello. Does everybody understand what I'm saying? Instead of earthling, I will modify that assignment so it says, instead of using the word earthling, insert your own name. So I will expect your function. I'm gonna load your code into my system, and I'm gonna try to run it, and I should see greetings, Courtney. They come in peace and offer an end to starvation, right? So I want to see your first name substituted for where earthling is. I should change that right now so we get that done. Okay. Any questions about the assignment and what's expected?
I don't think so.
There we go. Where earthling is shown in the greeting statement of the sample. Run it using the Python command with greeting.py. Example, Python space greeting.py. If you write that code simply enough, it'll run. Now hit the up arrow in your terminal and press enter to run again and run again and run again. Now that's just then capture a screen. Now, why do I want you to run it again and again and again if it's right? Well, I'm trying to hammer home in a very artificial manner the idea that, hey, once I go to the trouble to get this right, I can reuse it over and over and over again. And all I got to do is hit an up arrow. And that's part of the charm. It's a bit like trying to start a fire where there's sparks and kindling. And once the fire takes, it really gets interesting. It can change your life. If you catch on to how to program and it makes sense to you, you can make 6 figures doing what you love. You know, I just thought I would put a plug in here for another program that we have in computer science. There are a lot of students and majors. They have no intention of changing from their major, but they're good with technology and they'd like to learn more about technology. And let's say that you're in sociology. Well, if you find out that you're good with sociology and you want a career in sociology, but there's some really cool software that would make every sociologist's and every social worker's life easy, this is your jam, right? So what I'm saying is any discipline can make use of this. We should be teaching basic coding like any other basic skill, like reading and math. And I just got to put that plug out there. In fact, a lot of high schools are retooling so that they actually require it as a basic skill. Because in this century, a little bit of coding is going to come in handy. How many of you have smart devices in your home? Quick survey. How many of you have a smart device in your home? Let's do a quick poll, shall we? Let's ask everyone in the meeting, how many have a smart or connected device in your home. If you could, I'm going to say, if yes, please respond with what? Okay. Has everyone seen that on the screen?
Yeah.
Okay. And yeah, you know, and why am I asking that question? Well, it's estimated that by the year 2025, there will be 50 billion, not million, B with a billion smart devices connected to your, did I just, yeah, okay. Please respond with what? Oh, I get it. Kadani, I'm sorry. I need another cup of coffee. I said, can you please respond with what? And you responded with the word. Touche. Yes, thank you for that bit of humor, Kadani. We have a hand raised.
Oh, no, I thought we were gonna use it.
Okay. Okay. No, that's okay. I was just responding. I saw the hand raised just now and I wanted to know if you still had a question. So it's not very difficult after you finish 3.1, but what I want you to do is to get in there and try something very basic, but customize it for you and then use it. And then just run it. 1, 2, 3, just that easy. So you get the idea that this is good. I wish in the physical world, I had the same ability to do what we can do with coding. Learn how to work a thing once, store it in your pocket, and then just the next time you got to do it, oh, fix the engine. Click, or change the oil. Click, get the mail. Click, right? Life would be very interesting. And in our digital universe, you can actually do this kind of stuff. Online, I mean, in the internet. Any questions about our 3.3 assignment before I shift a gear and we share screens? Okay. I'm going to stop sharing and stop recording so that those of you that would like to share a screen to resolve issues can do so without worrying about that stuff showing up on YouTube. Okay.